All right, it's my nasty garage. All right, it's time. It is time to do the damper testing. Not much charge left on this thing, of course, because that's how everything works. So what I'm going to do here is I'm going to install there we go. I'm going to take off the factory pulley. I'm going to put the stay. You good? All right. Yep, take out the factory pulley. I pulled some data off of the factory ECU, not factory ECU, sorry, the Mtron ECU with the factory pulley already. Now I'm going to put the fluid damper pulley on it and then take that on. Then I'll put the Perrin lightweight pulley on it. No, other way around, I'm sorry. Perrin lightweight next, then fluid damper, then mine without the damper, then mine with the damper, and then the stock back on again to round out the test. So you will see stock again. I just took the initial data set on the stock. If you missed the last video where I was setting everything up in the Mtron, I have 2 idle settings set in the Mtron. I hit the AC button and the car will automatically idle up to 2,000 RPM. That's where the next data set will be. And then when I hold the brake, the ECU logs automatically. We're logging RPM. We're logging delta RPM, which is or the derivative of RPM. And then we're logging mass airflow and ignition timing just for data consistency. So the first step now is I'm going to take this pulley off and put the Perrin lightweight pulley on. Shouldn't take too long. It's a VA. It's got a lot of room in front of the engine. Hey, Connor. A lot of room in front of the engine, so should take like 5-ish or so minutes per. I am going to leave the AC off because it is a stretch belt, so I'll leave the AC off. Which may or may not affect the first round of data that I got. But since I'm putting stock back on at the end, then I'll have it without AC at that point as well. So it's only going to be the main belt with alternator and power steering. Put the stretch belt on just seems pointless to me. So. You know what? It was cold in here, which is why I have all these jackets on, but I closed the door and turned the heater on for this portion of it. So let me take this off. There we go. Then I crank the heater up. I'm sure the wife's gonna love that when she sees the power bill or the gas bill. This is not electric. Shoots. This thing is great. It's a Milwaukee electric impact. They have 2 versions of the 3/8. They have the high torque and they have the high speed. This is the high speed, very low torque. Which honestly is kind of a bummer sometimes. I wish it had more torque, but it is what it is. So. I'll get it off. Maybe leave that on. Get that loose. Let's take the alternator off. I don't know where I was going with that. I was in disassembly mode, tear it all apart mode. My 22, where are you? It's over here in this case. $21. What the heck? 22 is missing. There it is. got her in gear with the brake set. Ow, put that skin back. I think I'll see that shirt. Belt. So excited to do this. I've got to take the AC belt off. So. Oops. It's a little warm, but luckily not too warm because it's been like 20 minutes there in the car. Stock pulley. Set it right here. Fix that camera a little bit. There we go. All right. Hair and lightweight. Really light. I should get the scale out, huh? Show you guys the measurement difference, the weight differences. Fun fact, when you're tightening these, when you feel that spring, there's two things you're up against. One is just the natural spring of the parking brake and the hub, but the other is actually the spring on your clutch. Your friction plate has springs in it, right? The springs on the clutch. That's one of the springs you're compressing. I didn't torque that to spec. I don't think it matters for this short of a duration. Obviously, it's really tight. I really lean on that thing with a 2.5 foot breaker bar, so that's as tight as I'm going to do it. And it's going to come off here in just a few minutes anyways. So it isn't like it's going to run itself off going down the road or anything like that. Now, I don't want to do it finger tight, that'd be silly. The woodruff key would get annihilated if I had this too loose, especially for any period of time. We're not going for that. Parent pulley is installed. Let's go inside the car now and get some data. Let's see what we can do here. Whee! Turn this down and choose the other camera. Bloop. So the reason I did this first is because I initially had a little bit of doubt, or I have a little bit of doubt about the resolution of this reading. I talked about that in the last video. So what we're going to do here is see if that changes with this pulley. Oh yeah, and I need to open the garage door so I don't carbon monoxide myself again, like I did this morning. So let me go do that real quick. Let this car finish warming back up and stabilizing. All right, so RPMs haven't quite settled down yet because it's still a slightly higher temperature. So I'm going to do a PC log right now just to see what kind of readings we're getting while it's warming up. See if I see big differences between stock and this. This should be one of the greatest differences. Well, the fluid damper or mine, in theory, to this one should be the biggest differences in DRPM. So we're hoping that the resolution is high enough to show that. I don't think that one counts. That just doesn't have the resolution that the EC login has, does it? RPM's almost steady. Let's go over here real quick, take a peek. We're at 1,000 right now. We're trying to get her down to 900. That's where I did my initial test on the other one. As she warms up, that RPM is going to start dropping. So what I have done is I've locked the idle timing to minimize the input of timing on crankshaft position. Now, unfortunately, it is creating a little bit of oscillation on occasion. I'm going to be sure to pull data when the oscillation is not occurring. So I want to get a steady state RPM read. All right, we're getting pretty steady. I'm going to do an ECU log now. And 1, 2, 3, 4, 5, 6, 7, 8. Just do that. I'm going to ignore the first couple seconds of it because, as you saw, there was a surge from the Heron idle test. There was a slight surge from the vacuum entering the engine, causing the idle to fluctuate. And you can do that actually if you were so inclined one time. If you stand there and pump on the brakes really hard, your RPM will climb up. But that took a long time. That took a long time to download that one. I wonder if there's other logs on it. So we will open ECU log, parent idle test. This is that log file. We will go to the end because we don't want this stuff in the middle because we weren't even there for this. Well, that's weird. It didn't record anything. Weird. Let's do it again. 1, 2, 3, 4, 5, 6, 7. Turn off. Oops. That's the onboard memory that I'm erasing. Uh-oh. My battery died? My battery died on my little open ECU log on my parent idle test. Have this. There we go. Let's see if I can do this up. Okay, maybe I can lock it. And lock this bitch in place. Where's the lock for this thing? Don't see it. Bummer. I'll hold it. All right, close. Oh no, that's not what I want to do. I made it too short of a time. There we go. This is supposed to be the biggest change, but I ain't seeing shit. And that was kind of my fear. Maybe this resolution isn't good enough for that. Well, let's try to 2000, and then I'll export the data to a CSV. So the thing that I was concerned about was that even though I have the logging rate really high, this value, this DRPM, is averaged over 4 samples. So you can see, if you look straight on, it's a straight line between these 4 samples. And then these 4 samples is the next line, and the next one. So there's a lot of chat that hasn't gone on. Connor says, I hate Governor. Will varying the alternator belt tension affect the data? It should not, because the alternator is still coupled, so it shouldn't affect that. I dig the cart. Yeah, the carts are great, honestly. Don't break a nail. Har, Paul. Think this would take out the vibration and have a 2K? Probably not. I don't know what your vibration is, but that's not what they're for. Yeah, that's not really what they're for. It's, I mean, no. Typically what you're feeling there is going to be either, if it's torsional, it's a resonance, but otherwise it's going to be misfires or balance issue. I don't think that if you get a perceivable vibration, I don't think that it's going to be a damper related. It's possible, but I don't think it is like going to be the case for that. We're looking at on a small scale. That's why I'm concerned here about resolution, because I'm looking at a small scale, trying to get data in a very very specific and particular type, so that I can see, you know, what the crankshaft is doing over time. But this right here is not really showing me much. This averaging is what's concerning me. So this, on the other hand, I dig. That looks like it's pretty accurate, but the other stuff is not. So we're gonna raise raise our test RPM up. Man, words are hard today. So I set that up. So if I hit my AC switch here, I gotta turn this on first. AC switch, then it goes to 2000. Here it rev up on its own. That way it's independent of me. It just does it on its own. It's got a fixed timing value again and all of that. So 1, 2, 3, 4, 5, 6, 7. Enough of that. And we'll go here. Download EC log. So as we parent test, this is 2000 RPM, not idle. It's kind of loading up, which is weird because it's got an O2 sensor and it says it's stoic, but look at that. It's kind of cloudy. It smells funny. I wonder if the low ignition advance at idle is not giving me a clean enough burn. Okay, so let's now open that one. So we're going to open EC log, parent 2000 test, and go. Okay, now we're seeing some more movement here. Let's zoom in a bit. Let's find the steadiest place we can. I just did this earlier and it let me freaking grab it and drag it. Now it's not letting me do it. You're dumb. You're dumb, software. $45, $44. If you look at this time signature, this is from 3.6 seconds to 5.6 seconds is what I'm looking at, kind of this area right here. I want to ignore the big guy. Just trying to get these minute changes, these small changes, and see what kind of magnitude we're talking about. Now, right here, obviously just scanning through it, looking at it. It's not a very professional method of analyzing the data, but that's why I got it saved, so that I can export it to CSV when I'm done, and then put it into graphs and see what kind of changes we're seeing between these pulleys, if any is perceivable on this through the software. I'm hoping, obviously that's why I'm doing it. But I mean, if we look at this sample, like there's a big change right there. I mean, this, according to this, the crankshaft speed is going from 2010 that was only 1997. But I mean, you could look at this and see what I'm talking about. I mentioned torsional vibrations as things are slowing up and speeding down on the crankshaft. Right? Look at this. So there's crankshaft speed, 2008.
And then just a fraction of a second later, 1998. A fraction of a second later, 2008. 1998. 1997. 2000. So we see that at this RPM, you still have some variance in the crankshaft speed. And that doesn't seem like much, but if you think about that, that's the crankshaft spinning and speeding up and slowing down as it's rotating. So what we're trying to do is minimize these changes, the amplitude of this variance. That's what we're trying to do. So I'm going to go from this one, which is a known lightweight one. Revs pretty quick. And then I'm going to go and put the fluid damper on, which is a known heavy one with damping. So that's the next step. Let's put the fluid damper on. Now that the engine's nice and hot,
Oh, it goes up. I want to lean downward. Can I make it sag down? Let's see. My gimbal ran out of juice. I mean, it's a cheap one from Best Buy, so I mean, it's not like it's totally unexpected. But I would like for it to at least hold still in one direction. See a rubber band. I'm also gonna close that door. Some air moving in here. Is that working? Can you guys see that? YouTube's telling me, rotate device. Like, fuck you. This is what I want. Ooh, hot. Aaron? Now flute. Shit. I can't do the fluid damper. I have a timing cover that's trimmed on here. I have to get another one. Oh, it's fine. Bring it. So to explain what's going on, you look at here, there's a groove in the back of this. That's to fit the timing cover. Fluid damper didn't have that groove. They decided that groove Wasn't worth it or something. I don't know. So that's a bummer. Parent has it. Factory has it. I have it. I have something actually that Fluid Damper did. They add the chamfer to the back here. Factory does that. They have a chamfer on the back. Parent doesn't. It's pretty square. That chamfer's purpose, as far as I can tell, is just to help with the time belt in case it starts to walk forward, help push it back gently without shredding it up. It's the only thing I can think of why they'd be there. But I did anyways because the factory had it. Really, in those cases, the factory gives there's a reason. They often don't do anything without a reason. Because anything extra is extra cost. Extra cost means cars are more expensive, means you sell less of them. Or you make less per car, depending on how you look at it. So why add an extra process? I mean, it's not much of a process, but it's another edge. Why add the edge if it's not important? That being said, I don't know if any parent lightweight pulley equipped cars have thrown timing belts or not, or shredded the front of them. I have no idea. That's obviously speculation as to why it's there, but it's the only I can think of. Well, that's what it is. Phone's going everywhere. See anything? But that's a fun watch right there. Sorry about that. All around the world, 8 people at their computer puke. I'm getting seasick. All right. Mine is in place. Wow, it starts easier. Sounds better too. No, just kidding. That's obviously not true. That's the kind of shit you see on the internet, though. Like, oh man, I know as I started my car, immediately ran better. Oh wow. No, dude, that's not how it works. Still feels pretty snappy. It is heavier than the parent. That part you can tell. You can tell in revving speed between different pulleys by the weight change. But that's barely perceivable in this case because it's not a huge weight change. Okay. She's almost steady here after starting. So let it stabilize again. I hear it hunting a little bit. There we go. There's some steady time. Let's do it. 1, 2, 3, 4, 5, 6, 7. Off. All right. And
Let's download that. GDT test idle. Enter. It's a lot of downloading. Might not have to leave the other stuff. Let's see what happens. 7 file OpenEC log GDT idle test. Did it again. Did that 0 thing. So apparently it's logging while it's off. But there's mine. All right, let's do it again. Wait for it to stabilize. Since it was being weird. 1, 2. Figures not do it. Freak out. Okay. Let's look at it again. Log in. ECU, download log. I'm going to overwrite that one. Way faster. Open it. Okay, we see those oscillations that we had. Let's zoom in on a flat section like it did on the other one. And check out the step change. Oops. Let's go check out the step change between sampling. $9.15, $9.11, $9.15, $9.09, $9.09. And it's going down over time here. Step change again. 9.13, 9.08. Oopsie, I don't want that. God damn it. So some pretty small step changes there. That's pretty cool. I don't know if that's from the day up or not. We'll find out when I export that data. Let's do a 2000 RPM one. Let it stabilize. Come on now. Just not a little bit right now. One, 2, 3, 4, 5. Back down. Download EC logs. This is going to be GD 2000 test. Yeah, series EC logs. 7. Open EC log. GDT 2000. Close. Alright, zoom in on a section like I did before. See how big my steps are. $1997, 91, 96, 92, 87. Okay, so now this is, like I said, this is just quick analysis of it, but these steps in between sampling are smaller than the parent pulley was. These are about 7 RPM, where the parent was 10 to 15. That's 5 RPM, 4 RPM. So in the sampling range right here, each one of these little guys is closer than the parent. Twice as close. See, that step size is way smaller Now, it might look the same on the screen, but that's because the axis changes based on what we're looking at. But in between here, we could look at it. 92. Come on. I'm right there. 87, that's 5. Oh, damn it. Yeah, what does that? So we're looking at 5 to 7 RPM steps instead of 10 to 15. Yeah, 5, 4, 5, 96. Here's a bigger one. 96 to 88. That's still 8. 92, 4. Yeah. So that right there looks like it's already twice as good without even putting on the damper. Now, that's just a matter of adding mass to it. Let's open the factory one real quick. Let's open that factory one again. I didn't do it this way before. Let's see, where's stock? Stock, idle, don't want stock 2000. Now let's see stock 2000. Come on. Stock 2000. All right. Close. Stock 2000. Now you look at it. Oh my God, that's so big, right? It looks like this big old squiggly line, but look at the axes. This is 79 to 89 to 200. So that's 20 RPM. These are only much smaller steps. That's why we gotta zoom in. So we'll zoom in on a spot and see how big these increments are. $1993, 1981, 1993, 1987, 1999, 2000. Oops, don't do that. Oh, I hate when it does that. 2006, 1990. Huh, this is larger. The stock one here. This is closer to the parent one. That seems weird to me. Of course, the parent is on a rubber isolator, but it's not as large as parent, but it's up there with some of these steps here. 69, 7, that's 10. 73, 86, that's 13. Interesting. I am intrigued. Let's find the zone. Just to see, maybe that was just a weird zone. Let's move this over. Now these squares all look about the same size, don't they? What's this one? 89, 75, 83, that's a little closer. 72. So yeah, we're 10 to 12 averaging out here pretty much. Interesting. Okay, let's turn it off. Let's bolt on my damper, see what happens. The cool thing about my damper is I'm not taking this shit off. It bolts right to the front of it. What if I get this to stay so I can show you guys how this works? Probably not. Excuse me. Try to get this to stay here 1 second. Apologize for the earthquake. It's as good as I can get it right now. Let me grab my damper. So this is my damper. It is full of a silicone fluid that I have all over the place because I just filled it up and I spilled a bunch doing it. It's got 4 chambers, or 4 sections, and each section has 4 chambers, so it's got basically about 16 chambers in it. It pilots on the center hub hole that I have cut in my pulley, as well as locates on 4 posts into the 4 bolt holes in the front. Those posts and bolt holes I have about the same diameter and distance as the factory pulley, and my hopes were that if he had to do a change of the stretchy belt, and he used the Gates stretchy belt tool instead of doing it by hand or some other way, that you would be able to do so. You would be locked out of it. With all the other aftermarket pulleys, you either got to buy their special belt stretching toolkit. I'm talking about Green Speed in that case, or you have to do it another way because there's just nothing. There's no provisions for it. That didn't make sense to me. I figured if I can build it, I should build it. Right? That's too long. I need to short it out. This is a little shorter. Let's see if this is short enough. This is the only hard part. Nope, just use a regular wrench. I want to get all fancy with it. Just 5mm Allen on those. I thread them in the rest way of my hand. And we'll tighten them. So there's a center bolt in the middle of it. You may have seen that before in pictures. That center bolt is not what holds it to the pulley. The center bolt is what holds the two halves of it together. Right now, it's not welded. It's not held together like everybody else's damper is. Mine, you just unbolt the center of it and the damper comes apart. And then you got 50 cc's of silicone fluid all over the place and no way to fill it because you don't have the tool that I made to fill it. But you can look at the inside of my patented design, but then your SOL when you open it, because honestly, if you go opening it, I'm gonna tell you to F off. I got a big old sign that says "Do not remove center bolt." It's the wrong size, Alan. It is the wrong size. It doesn't feel right. It was in the 5mm slot. What the 5mm? It's not loose. This one's fine. I'm sure the view is great. My wrist. Check out that soft, supple wrist. Yeah, it's fine. Nice and tight. Now, the thing about this is that you can't bolt this on before we bolt the pulley onto the engine. That's the only caveat. Because there's a bolt-on damper. It covers up the crank bolt. So the crank bolt's got to be on and torqued before you bolt this on. Now this right here is the very first time that this damper's ever been bolted to an engine. I haven't done RPM testing yet, so for all I know, this thing just fucking fail and shoot pieces all over the garage. Make for a hell of a video. Grown man crying in his garage, but I won't cry in my garage. I'll wait till I lay in bed or in the shower with my clothes on. Okay. tool. We'll check this guy. Make sure it's tight. This is pretty good.
Yeah, this thing's never been on an engine before. Plenty of room. I'm gonna start it, look at it while it's spinning. See if it looks like it's gonna blow itself to pieces or not. Oh man, my car backfires now. What did it do? I'm just kidding. Look at that thing. Running so pretty and true. I also swung off the oil that I put on that extra oil I spilled. My alternator sounds quieter. That can't possibly be something, but the alternator and power steering sound quieter than they were earlier. That must be a heat thing. Can't see a damper making that big of a difference. All right, so we're at idle. Let's just do 5 counts. 1, 2, 3, 4, 5. I'm not gonna lie, it feels smoother, and that's probably a placebo effect or confirmation bias or something going on, but the car perceivably feels smoother. I should have cleared the ECU log before I took that one, because it's gonna be a long fucking log probably. Yeah, I should have cleared it. Wow, it's so good at 0. No, I'm just kidding. Obviously not the case. Let's see here. $432 to 434 seconds. 908, 904. Come on. I gotta zoom in. How to get this scaling to zoom in more? Don't remember how to do that. Let's take another one. Fuck it. 1, 2, 3, 4, 5. Okay. ECU logger. Download. Damper idle. Save. F7. Open ECU log. Damper idle. Open. Close. Alright, zoom in. Wow, that's less Fiscata than the factory one was showing us before. Oh no, that was 2000 we're looking at. Not 2000 right now, but now we're sitting here at idle. And 13, 9, 16, 9, 11, there's a 5, there's a 6. 5, 4. Was that 6? Was that? 6, 19, 17, 13. Wow.
Where's a big step? I think that's the biggest step I got here. 15 to 6, so that's a 9. Here's a 18 to an 8, that's a 10. But overall, there's some pretty small steps in here for idle. I like that. I like that a lot. Look at this. Look how small those steps are right there. 24, 22, 25, 23, 25. We weren't getting that at all on the other one. Let's do 2000. Stabilized? There we go. 1, 2, 3, 4, 5. Alright, some big old things going on right by that appearance. Let's zoom in, see what we get. How big are my steps? These might be kind of big. I might have induced a resonance somewhere. Let's see. 93, 82, that's an 11. 82 to 93, it's 11 again. 89, 82, whoops, 90, 78 to 89, that's 11. '02 to 89, 94 to 82, 92 to 80, so 12. I should have wrote this all down, shouldn't I? I think I remember what I had. 92 to 04, 12. 97. So it looks like we made about 12. It's almost exactly 12. Almost all of them. Got some smaller ones. 14. This looks like a 12 again. Yep, there's a 2. 15 to a 5. 6 to a 17. Yeah, they're pretty consistently 10 to 12 on this one. With my damper on here, 2000. Now, the cool thing about this damper is that I have the ability to tune it. I made it so that I can tune it and adjust the resonance, the bypass flow to give it different spring rates at various RPMs with the 16 chambers. And like I said, this is the first time it's been on a car. So, okay, so this was 2000. Let's do 2000 with just my pulley again. GT 2000. Here's the pulley. Zoom in. Because it's possible that the damper could find itself stuck on one end or the other with a resonant frequency somewhere. 93 to 89. So I had less without the damper at 2000 RPM on the last test. So that means I could have very well found a resonance with it, which means I just need to keep tuning. Let me give it a couple revs. Do another test at 2000. Oh, that fuel. Test stabilize. Clear my logger. And go. 1, 2, 3, 4, 5. Okay. Bring that down. Download logs. I'm gonna say GT damper test number 2. 2. Save. Well, that was annoying. It's not what I wanted to do. Where's my thing? Come on. New log. Seven. 96. That's 11. 4. 10. Yeah. So it is better at idle, but worse at 2000 right now. So what would that tell me? Right now I have the 100 weight silicone fluid in it. I have a 50 available. I also have control over the bypass rates in it by changing the clearance between some points in the pulley hub that I have in there. So the question is the pulley just find itself parked into position because the fluid is too thick, and at a higher speed doesn't get a chance to move, and at lower speed because it's a little higher viscosity it's able to dunk back and forth inside there and absorb damping vibrations, and as RPMs go up it's too thick, it moves too slow. So if I run the 50 weight, would I get more action out of it? That's what it looks like. It looks like it's, because I mean it was significantly smoother at idle. It was really smooth at idle, but definitely not as smooth at 2000. So that's where testing comes in, obviously. So I need to change my fluid viscosity, which is a fucking mess, and then retest and see if I can get these jumps down. Now, what's cool is that while it's not as high of a resolution as I would like, it definitely provides me the information that I need to better tune this thing. I can't do simple math with it because it's not just a slug in a viscous fluid like a fluid damper. They can go through and they know what the coefficient of friction is and of the fluid and the mass and the distance from center of their slug, and just rotates in this thing, so they can calculate the spring rate. Mine is 100% coupled, so mine's free to move a certain range, and that's it. It isn't free to spin on its own anywhere past a certain range. So the concept of mine is that it's allowed to move to the end and put all of its energy back into the crankshaft, not some of it. And so what I have to time that spring back and forth so that it's able to transfer energy over a wider range. Now, what's cool about it is I have all these chambers in there, and some of them are self-correcting. As long as I get the viscosity correct, what will happen is I have all these fluid paths in there. So as the speed increases with the damper, so if I use a lighter viscosity fluid, for example, as it increases the speed, it increases the displacement rate, and one of those displacement paths is opposite the direction of damper travel. So it exponentially increases the friction on the damper as the damper accelerates. So what that means is that I can get away with a lower viscosity, and I don't have to run a thicker viscosity, but also it gives me a wider operating range. And clearly, well, I think clearly, we'll see what happens when I do the next step, I have too much viscosity in there. It looks like the slug is not moving anymore, like it's just stopping in there. It's not really providing a lot of damping at a constant RPM at 2000. At idle, it's got time to move inside and transfer its energy because it's much slower RPM. And I feel like it probably still isn't even traveling its full range, its full distance. So I am going to change the viscosity of this oil and do the test again on it. Now, unfortunately, that takes me a long time. So I got to take this one apart, which is a pain in the ass once put together because everything sticks. Then I got to drain it out. Then I got to clean all the components, get all the old viscosity oil out of it, and then I have to refill it, which is a pain in the dick too. So it won't be in this video, but I'm going to go do that now. And also, to be honest with you, I'm not showing you guys the inside for a reason, because right now I'm still working on patent stuff for it, because I've done a lot of searches and nobody has a damper like mine. I found one, that's not true. I found one that was kind of similar in an industrial setting that they use on some pump motor thing, but it was just based on one principle, whereas mine's based on 3 separate principles, and it only had 2 chambers, and it wasn't even based on displacing fluid in the chamber. It was just a weight that hit these limiters. Mine displaces fluid and all this other stuff. So I haven't found anything like it in all of my searching, and neither has my lawyer. So I think it's going to be a patentable item, and so therefore I don't want to show you guys the insides yet, but hopefully that won't be too long before I can do that. So as of right now, I still haven't tested the fluid damper because I got to change that front pulley, or front cover, which is a pain in the butt, but I can do it. So I have to change the front cover and do the fluid damper and see. Maybe the fluid damper will be afflicted by the same thing that mine is and have almost no damping at 2000 RPM, but have superior damping at idle. That's what mine has. I don't think it's going to be as good at idle. I think the fluid damper will exceed this at 2000 RPM, but I think the fluid damper will start to lose out at higher RPM. I haven't done those tests yet because I still want to see what's going on here. I should probably do a 6,000 RPM test or something. Let's do a 4. I'll do a 4,000 RPM test, but I'll do it with my foot. Clear my ECU logger. I have the 100 in here, 100 weight in here. I'm not going to have a lot of opportunities to One, 2, 3, 4, 5. Forgive the shit out of it. Figure. Let's see if that damper can hold itself together. What's your resonance thing? So far my damper exceeded all of them at idle, but it did not do better at 2000 RPM. And I just did a 4000 RPM one for my own data so I can compare it to the 50 weight when I get to that point. Three, 876, 3878. 3875, 3875, 3859. Okay, there's a bigger jump. There we go. 3875. He's doing a little more. Those jumps are too big. I can't see them. Can't get between them. There we go. So 4,084, 68. 60, 70, 85, 83. Okay. So that's my 4,000 RPM data. I will do that again with the 50 weight to compare the two. And then I'll put one of the pulleys on and see what it does too. So I do those at 6. But this is for my data, so I know as I change my fluid viscosity, how much travel I'm getting on my slug. All right. Well, that concludes today's testing for this video at least. So again, what did I learn? Well, I learned that I wish this camera would turn around. I suck at phone. I keep hitting the button, but nothing's happening. There it goes. All right. So I learned that the stock wasn't as good as I thought it would be at idle, but it was better at 2,000 than I thought it would be. The Perrin was it twice as bad at 2,000 and not as good at idle, or vice versa? Oh, it was twice as bad at idle and not as good at 2,000. And mine was really good at idle, which is that was pleasant to find that out. It was damn good at idle, but it wasn't as good at 2,000. So I need to adjust the damper and then do some more testing. So I'm not totally bummed out because I'm happy that it showed. One, it showed that it wasn't a total success, because I want people watching my videos to see the process, and to see the failures as well as the successes. And I hope that helps to enforce that I try and be as genuine and accurate as I can in my product design and development, as well as in the data that I report to you guys, and the facts or opinions that I tell you guys, that you guys understand that there's reason behind it, actual scientific methods behind it. I fucking hate saying science because media right now and our government has gone overboard with the usage of the word science and using it in ways that aren't even actually science. It's crazy. And I don't want to confuse opinion with science like those people are doing. So, like I said, scientific method, that I'm trying to do things as accurately as possible and show you guys, like I said, the successes and the failures. So, what was the success? The success was at idle, and the failure was definitely up higher. The other thing too is I get to take this one apart, measure how much fluid is in it still, see if it sprung a leak while I was running it, see if my outer O-ring held. I've had that thing together and apart like fucking 20 times, showing people and testing stuff, and I don't know if I pinched an O-ring. Maybe during that test, it blew all the oil out of it all over the car because there's still a lot of oil over the car. So, I'll see if maybe I blew an O-ring on it too, and that's why it wasn't working as good higher up. I got some messages I didn't see coming in, so let me see if I can answer some of those real quick. If you're pro damper or ultralight, just want to stumble this live stream. What are your thoughts about running a lightweight flywheel and a fluid damper as a way to further balance the front and rear of the crank? Balance. I don't think that you're going to achieve any change in balance by doing that, because the back of the crank, where the flywheel is also piloted onto the input shaft of the transmission, which also has a gigantic bearing on the front of it that's going to be supporting load. So I don't think if you had a heavier flywheel back there and a lighter pulley on the front and you hit a jump, that all of a sudden this really heavy flywheel in the back is going to cause the crankshaft to have a rocking moment. Or a rocking couple, or whatever you want to call it. I don't think that's going to be the case.
And I don't think that's the case because, again, it's being suspended also behind it. It's the fixed end of the crankshaft, whereas the pulley on the front is the free end. So I don't think balance is a concern at all with that. In terms of damping, you can attempt to make up for some of the flywheel lightness with a heavier damper, but you got to know that it's going to be way skewed towards the flywheel. The flywheel has a gigantic diameter and the pulley has a very small diameter, right? So I happen to have both of those right here. If I pull a pound out here, just a pound, I'm going to have to add 3 or 4 pounds in here to equal, right? It's not, it's, yeah, I think that's what, radius squared? I'll have to double check on that. But you have to add a lot of weight to compensate for what you take out of a flywheel. So do I think that you're going to achieve that? No. I think that you'd have to add so much weight to the front of the crankshaft that you would make the crankshaft fail. So I don't think that you can totally counteract what you've taken out of the flywheel. Yeah, I don't think you can really. And you can do your best, and that's why I'm trying to make this damper as effective as possible so that I can do more with less. If I have this energy stored and I'm able to release the energy in a short enough period of time, then I have an impulse, and that impulse can dampen or reduce how much the crank slows down, because I can get it kind of quicker. Obviously, if it was loose and floppy with no silicone fluid in it, then that impulse would be basically like a hammer hitting on it and would not be good for the engine. But I just wouldn't be good for the crankshaft pulley, really. The crank probably be fine, but oh, it cleared up. Stop snowing. I can see all the way down there. Oh, that's pretty. Yeah, so I don't think you're going to get the result that you want out of that, or at least, I mean, you know what I'm trying to say. I hope you know what I'm trying to say. If not, ask again. Good to go. Back in a big, excited to see the results. I bought a fluid damper for my car. The factory one came apart in 2 pieces. Yeah, the factory ones aren't always that good after a lot of mileage because they're held together by rubber, and the rubber dries up and fails, and the outer piece comes out. On a trip to go skiing. Next day, pulling out of my driveway to go to the gym, heard noise. No damper. Yeah, that sucks. And it's damper, not dampener. It doesn't make things wetter. To make things wetter, it'd be a dampener. But it's a damper because it damps movement. So it's a damper. I have a fluid damper too. I love an STID. The driver, peace of mind, knowing it's balanced. The instant it cranks. Well, it's not balanced. The black snow analysis hasn't shown any new bearing material on the oil since. Cool. Just right on. I'm going to test an ATI Instagram too. I don't plan on it. I don't know if I have one. I might have one. Hey, it's that fucking Sim Spanbot coming in here with Vask.tech. Bolt on BurbleTune? Fuck yeah, dude. All you do is bolt it on and she starts to pop more. Just do anything in NA engines. Cody. Yeah, I mean, it's not, it doesn't care if it's NA or turbo. It's all about the crankshaft and what it's doing. Different rotational masses with different firing orders, or I'm sorry, firing frequency, so like a 4-cylinder versus a 6-cylinder versus an 8-cylinder, will require a different amount of, or it'll produce different frequency between these different damper, weight, and viscosity and all of that. So if I have a 4-cylinder, for example, I have 2 combustion events per revolution, right? Because there's 700, it's a 4-stroke, right? So there's 720 degrees per cycle. So 2 combustion events per revolution, which means every 180 degrees, I'm having a combustion event. So the crankshaft is going to speed up and slow down twice, basically, per revolution. Now, if I have a V8, there's 4 combustion events per revolution. So now it's every 90 degrees. So this crankshaft is going to spin and slow down 4 times every rotation. And what that does, though, is provide you a smoother motor, because when you have a cylinder undergoing expansion, you have another one undergoing compression. And there's overlap. Whereas in the 4-cylinder, there's one of them's done with expansion. So it's expanding while it's compressing. But in the 8-cylinder, you have 2 of them. You have them in various states of expansion and compression at the same time. So basically, that ripple gets finer, smoother ripples. So you have a higher frequency. Typically, that's for the benefit of the 8-cylinder, because eventually, a super high frequency can become a straight line. I mean, I guess technically a super low frequency can too, right? But you can't get no frequency out of it. Sorry, I got some cookie here on the counter here. But what was I saying? Oh, anyway, so yeah, it isn't a factor of whether it's NA or turbo. It's just a matter of, is this damper going to fit into the right operating range or operating frequency and amplitude that this engine would have. So the 4-cylinder would have a lower frequency and in theory a higher amplitude, because the crankshaft, one, is speeding and slowing down twice per revolution instead of 4 times, and it has more time for each to occur, so it's easier for it to slow down. And since it has less mass on the crank and the flywheel and the pulley and everything, then it's easier to slow it down. So the 4-cylinder damper would have a much more difficult job than the 8-cylinder damper, because it has to deal with not only a different frequency, but a much higher amplitude. So yeah, it would work on NA or turbo. It just matter of it being tuned or not. And so what I can do with my damper, the way I have it set up right now, is the center plug on it can be used to tune the damper. I don't have to change viscosity, but right now I believe I need to change viscosity. I didn't think I was going to need 100 in the first place. I had assumed I was going to use in the 50, but I wanted to run the 100 anyways, just to test it. And it was too thick, as I thought. At least it seems to be that it's too thick. And that's what I had anticipated. But now I can take it apart and clean it unless I put the 50 in it. Now once the 50's in it, I'll do it all again. And the 50 should help it respond better at higher frequencies, and which is higher RPM. So I anticipate that it will do less well at idle, and then better at 2,000 and up. If I find that it still isn't moving quite enough fluid to give me full range of my slug in the damper, then I have 4 spots that I can grind down a little bit internally if I want, or my center plug, I can use that. I can turn down a section of that, and that will increase my bypass rate between all of those areas as well. So I have all of them. I have ports to all of them going to the center, so that all of the chambers are plugged right now, and they only go through the damper itself through all the pre-prescribed flow paths. But then if I want to increase the bypass rate, I can put another plug in the middle of it, which will increase the bypass rate and change the tuning of it. And what may happen is that I find that I have a different plug for a 75 millimeter and a 79 millimeter crank. I can easily see that. Now ATI and Fluid Damper and those guys, they don't sell a different damper for the EJ20, and I kind of think they should, but I could be wrong, right? That's what testing's all about. But I believe that I will probably end up with a 2-liter center plug and a 2.5-liter center plug with slight different bypass rates. Now, granted, the frequency isn't changing in those situations, but I believe the amplitude will. I can't be sure without testing, but I believe the amplitude will change some, and thus only a different bypass rate. But we'll see. We'll see what happens. So with that, I need to pee and wash my hands, cut my cat a little bit, answer all these messages that I've been getting, and then I'm going to take the pulley off the car because it'll have cooled off by then. I'm going to drain it out. I'm going to clean it out, put the 50 in it, and then I'm going to do some more testing. So I will probably fire up another stream for the 50 weight test to see how that goes. But I can't make any promises at this second. I also need to take some packages to UPS. Hopefully the roads are plowed though, because my BMW has DWs on it. So I don't have anything with snow tires on it that's running right now. My RS has snow tires on it, but it's taken apart. And the red STI that we were just in has R888s on it. Those are definitely not snow friendly. And hey, cut it out. Yeah, it's being stupid. Yeah, you and you over there. Anyways, so that's the rest of the day. That's what I got ahead of me, and I will keep you guys informed as to what I find. Eventually, I will get all of. Man, my phone just keeps blowing up. Eventually, I will get all of the data for all the data for all of the tests into a CSV, and from there, I will take them and put them in some spreadsheets and actually plot the data and take notes and produce a final spreadsheet that shows the difference between all the all the various pulleys that I tried. And if I find my cover, I know I have one somewhere that's trimmed. Yeah, that's silicone. You won't like that. Cat, she's decided to come up and say hi. Stop it. Then once I get all the data put together, then it'll show each pulley what its variances were based on the RPM ranges I tested. And maybe I'll do 6,000 for all of them too. Idle 2, 4, and then maybe 6. We'll see. I still like holding the car at 6,000 free revving for a long time for no reason. Accelerating and decelerating is not quite as bad, but a free rev at a fixed RPM for a long time, it's really hard on bearings. So I don't want to do that. And I like free revving anyways, but I rev the shit out of that last one just because I want to make the damper go spinny some. And test that O-ring, see if that O-ring's failing on the outside and blowing oil out of it. So anyways, I gotta go. I'm gonna go and take care of this stuff, answer all these messages, and answer some emails, wash my hands, get some lunch because it's 3 and I've only had 3 cookies and a bowl of cereal today, and then take that damper off, change the oil out, and continue on with the day. So for the testing. So thanks guys, appreciate you stopping by, and look forward to sharing the results of the next test with you.